So this is question 1 from the test review, and it says an object is launched at an upward velocity of 40 feet per second. That's important. The velocity is 40, so V equals 40. From the top of a building 200 feet above the ground. I'm not sure what this is going to be yet, but I know it's important. Use the vertical motion model, h equals negative 16t squared plus vt plus c, where h is the ending height of the object, c is the initial height in feet of the object, and t is the time in seconds, and v is the velocity of the object. So how long will it take the object to reach the maximum height, and what will its maximum height be? So we've been given a function, h equals negative 16t squared plus vt plus c. So then when we fill this in, I'm left with negative 16t squared plus, we just said v was 40, t plus, it also tells us up here that c is the initial height. So the initial height would be how tall the building is, which in this case would be 200. So now we have our function, we can use it. Remember that the maximum height, finding the how long it will take to reach the maximum height and what the maximum height is the same as finding the vertex. Because if you think about this launching, it's going to look something like this. And that vertex, that highest point up here, is going to be the point TH. T for time, because this is my t-axis, also known as my x-axis, but this is your t-axis and this is your h-axis. So this point, the x-coordinate would be the time it takes to reach that, and the y-coordinate would be the height that it takes to reach that. So just like with our axis of symmetry where we have x equals negative b over 2a, this time we're just going to have t equals negative b over 2a, which means I have negative 40 over 2 times negative 16. So negative 40 over 2 times negative 16 is negative 40 over negative 32, which would give me positive 5 over 4, because you could divide both of these by negative 8. Or you could say negative divided by negative is a positive, however you wanted to look at that. Now, because we're talking about time, I wouldn't say it took me 5 over 4 seconds. I would say it took 1.25 seconds. So that means that the first answer to this question is at 1.25 seconds. The object's maximum height will be blank. So then I have a function here that I can use to find that maximum height. Now that I have a value for t, I can say h equals negative 16 times 1.25 squared plus 40 times 1.25 plus 200. And when we put all of that in, we should get negative 16 times 1.25 squared plus 40 times 1.25 plus 200 gives me 225. So my height is 225. And if I look back at my problem, everything's in feet, so 225 feet. So it'd be at 1.25 seconds, the object's maximum height will be 225 feet. If you have any questions, post them below.